Hi. Now here I have 5 terms in a sequence. I wonder if you could tell me what the next term's going to be. Well, it's going to be 320. And the next term after that is going to be 640. But why is that? Well, you should have seen that we're multiplying each term by a constant value, and in this example we're multiplying each term by 2 all the way along. Here's another example for you. In this example, what are we now multiplying each term by? Well, we're multiplying each term by minus a half. 48 times minus a half is going to give me that minus 24. And if I multiply minus 24 by minus half, you get 12, and so on. So the next term in the sequence will be 3, and the one after will be minus 1.5, and so on. Okay? Now, when we get sequences like this, where we multiply each term by a constant value, they're called geometric progressions or geometric sequences. Well, quite often we're going to find that we're going to have patterns of numbers like these, for example, and we're going to need to know what a particular term is. I mean, it's all very well seeing here that the third term in this sequence is 40 and the fifth term is 160, but suppose you wanted the 100th term. You don't want to write all of these out. And also we're going to want to know what the sum of all of these terms are going to be. Again, the sum of the first 3 terms is clearly 70, 10 plus 20 plus 40, but suppose I wanted the sum of the first 100 terms. I'm not going to want to just type them all into a calculator and add them up. Far too long. So in this tutorial, what I want to do is show you how we can get general formulas for the nth term and the sum of the first n terms in a geometric progression. Now, in general, what we've got, if we've got a geometric sequence, is that the first term is often referred to as a, and we multiply this first term by a particular number, a constant value, which we'll call r. So the next term, the second term, would be ar, and we multiply this term again by that constant value r, so the third term becomes ar squared, and so on. The fourth term, ar cubed, fifth term, ar to the power 4, and this will go on like this. So this is a geometric sequence. We'll just put the word sequence there for the moment. So clearly you should be able to see that the nth term is given by a times r to the power n minus 1. So if I wanted the third term, n would be set at 3, and it would be ar to the 3 minus 1, ar squared. And you can see the third term in is ar squared. Now if it came to adding these terms up, we would have what is called a geometric series. So if I wanted to add them up, let's say a plus ar squared, and so on, we're going to use a standard letter for the summation of the first n terms. That letter is often written as s with a subscript n. It's the sum of the first n terms. So this is going to go all the way up to ar to the power n minus 1. The nth term being ar to the n minus 1. And it can be shown that the sum of the first n terms in a geometric progression is given by this formula, a bracket r to the power n minus 1 all divided by r minus 1. Mind you, some people prefer to use another formula rather than this one. If we multiply top and bottom by -1, you end up with a times, and we can switch the terms in this top bracket around and get 1 minus r to the power n, and we switch the terms around the bottom, because if we multiply this by -1 we get minus r plus 1, which we prefer to write as 1 minus r. They'll both give you exactly the same answer. So it doesn't matter which formula you use, but we tend to use this one when our common ratio, the multiplying number, tends to be more than 1, and it's a good idea to use this one when r is less than 1. But as I say, it doesn't matter which one you use, just generally. Now, I'd like to just do you a quick example on using these two formulas. We've got a sequence 4, 12, 36, 108 and so on, and we've got to find the sixth term and the sum of the first 10 terms. Now clearly this is a geometric progression. You can see that we're multiplying each term by 3. So when it comes to working out what the sixth term is, then according to our formula for the nth term, it's going to be ar to the n minus 1. A being the first term, which in this example is the 4, so it'd be 4, times the common ratio, which is 3, we're multiplying by 3, to the power n minus 1. We're looking for the sixth term, so n is 6, so 6 take away 1 is 5. And if you work this out on your calculator, you'll find you'll get 972. So the sixth term in this sequence, we've got the first 4 here, would be 972. Now admittedly you could have used your calculator and just got that sixth term very quickly by doing 108 times 3 and then times 3 again. That would have given you your 972. But this is just a quick example to show you how you can get a particular term in the sequence. And when it comes to finding the sum of the first 10 terms, then we're looking at S10. S10, n being 10, is given by one of these formulas. So I'm going to take this one here because the common ratio is 3 and it's more than 1. But you could try the same with this formula and it will still work. So for S10 it will be a, which is the 4, times the common ratio 3 to the power n, 3 to the power 10 in this case, take 1, and then it's divided by r minus 1, 3 take away 1. Work that out on your calculator, and what you should find you get is that it comes to 118,096. Okay? Well, that's just a very brief introduction to the geometric progression or geometric sequence, and I would certainly encourage you to look at the examples which follow because they take this a bit further, but still we're using these formulas. Okay, well that brings us to the end of this particular tutorial.